Hello, welcome back to our channel. Today we are going to discuss about physics crash course. The chapter name is the atoms. First of all, what is the atom? You know that atom is the smallest. Before 19th century they said that is the smallest particle. Then later they discovered and they said that we can split the atom also. And atom is having the spherical shape. Atom is having the spherical shape. Entire mass of the atom is concentrated at a single point, that is called the nucleus. Before that, many people they have given their own assumptions about the atom. In that, first person is the J.J. Thomson effect. What he said, J.J. Thomson atomic model, he explained that atom is having the spherical shape. Here inside that positive charges are there, as usual negative charges are there. Seeds are representing the positive charge, but remaining reddish seeds are representing the electrons, negative charge, remaining part is representing the positive charge. This is about the J.J. Thomson atomic model. But anyway, it is failed afterwards. You know that Rutherford come and Rutherford explained that what is the shape of the atom, what is the shape of the atom, what is the size of the atom, what is the size of the nucleus. And he said most of the atom is empty, and here electrons are revolving around the nucleus, and inside the nucleus positive charge is there. So everything he explained based on that Rutherford's alpha scattering experiment. What is the Rutherford alpha scattering experiment? He took one thin gold foil. Look here how much it is, 2 into 10 to the power of minus 7 meters. When the alpha particles are coming from this and these are scattered, and he observed that some scintillations on the screen, like that. He observed that some scintillations on the screen. But when he observed that spectrum and he given his what is the clarity about the atom and all this, I am explaining based on this. Look here. First of all, look here, this is the, we should consider this is the atom, this is the nucleus, and this is the atom, like that. He said it is having the spherical shape, it is having the spherical shape. When alpha particles are coming, when we are sending 8,000 of alpha particles, he observed that most of the alpha particles are passing through that one without any deviation, like that. Without any deviation, these alpha particles are moving. And few are deviating greater than 90 degrees. Few are scattered like greater than 90 degrees, and few are less than 90 degrees. Less than 90 degrees, and few are greater than 90 degrees. And he said 1 in 8,000 is retraced back. Look here. When we are sending 8,000, 1 is retraced back. From this, what you are understanding, you know that alpha particles are having the positive charge and nucleus is also negative charge. Because of that reason, what happens, these positive charged particles, nothing but alpha particles, are retraced back. That's why he said most of the atom is empty. That entire mass is concentrated at a single point, that is called the nucleus. That too, he said alpha, this is positive, that's why repulsion. And here some gap also you can observe that this is the closest approach, closest path of the approach also. You are saying that here some gap is there, and here impact parameter. See the perpendicular distance between these scattered particles and this deviated, this one is called the what? This is the beta. This beta is called the impact parameter. Look here, beta formula is Z E square cot theta by 2 4 pi epsilon naught K alpha. K belongs to kinetic energy of the alpha particles. But you must remember this formula. Impact parameter is directly proportional to cot theta by 2. What is the theta here? Scattered angle. Look here, you must remember that here closest distance of approach. The distance between the nucleus and that alpha particles, this gap is called the closest distance of approach. And here B is the impact parameter. That is the impact parameter means initial alpha particles, and this one scattered, this one is called what? This is the impact parameter. This is called the impact parameter, like that. This is the scattered angle. This is the scattered angle, and we should draw like this. And here theta is the scattered angle. Theta is the scattered angle. So now we know that. And he said that size of the atom is 10 to the power of minus 10 meters. Size of the atom nothing but radius of the atom is the 10 to the power of minus 10 meters. Then radius of the nucleus is the 10 to the power of minus 15 meters. And here some drawbacks also is there. He didn't explain, this is for another atoms also, he didn't explain that why electrons are revolving around the nucleus also. Then one more person came, Bohr, he has given much clarity about the atom, and here also some drawbacks are there. Anyway, in this what you should remember, when alpha particles are moving, those are having kinetic energy. When these are coming towards the nucleus, kinetic energy is converting into electric potential energy. Why? Positive charge, positive charge. That's why we should write it half mv alpha square equals to 1 by 4 pi epsilon naught. Charge of the alpha particles is the 2e, and here any atom we are taking, that's why this atom, atomic number I didn't write, Ze I have represented. This is nothing but Q1, this is nothing but Q2. Q1 is nothing but alpha, Q2 is you don't know about the charge, that's why we are taking Ze, and this is the 2e, Q1 Q2 by R naught. This is the potential energy and this is the kinetic energy. After simplification, you are getting the expression for closest distance of approach. Look here, R naught equals to 1 by 4 pi epsilon naught 4Z E square by M alpha V alpha square. So you must remember the charge of the electron, charge of the proton, or charge of any positive particle, negative particle, that is 1.6 into 10 to the power of minus 19 coulombs. Here V alpha is representing velocity of the alpha particle. So you must remember, you have to by heart these formulas, then only you can able to do the problems. Then come to impact parameter. It is possible you should remember this formula, otherwise at least you can remember that B is directly proportional to cot theta by 2. B is directly proportional to cot theta by 2. Sometimes they are asking the ratio, sometimes they are giving the scattered angles, you can find out the B1 by B2. So based on the situation you can deal that one. Then come to this one, how many number of alpha particles are scattered is equals to Q into N into T into Z square by E to the power of 4 8 pi epsilon naught square R square E square sin to the power of 4 theta by 2. See, here Q is the charge. So this N is directly proportional to charge, directly proportional to number of alpha particles. This is the thickness, Z is the atomic number, E is the charge, and R is the closest distance of approach or radius, E is the energy, and theta is the scattered angle. So you must remember this one, otherwise at least you can remember that N of theta is directly inversely proportional to sin to the power of 4 theta by 2. Inversely proportional to sin to the power of 4 theta by 2. So this is about the number of scattered alpha particles, and this is about the closest distance of approach, this is about the impact parameter. It's difficult to remember these formulas, but you should by heart. Still some time is there, daily once you look these formulas, but because it is very simple chapter, so no need of doing so much of hard work. When we know the formulas, easily we can do the calculations also. Then come to this one. After this, who came? Bohr's. He explained that Bohr's atomic model. According to that, what he said, these electrons are revolving around the nucleus in circular orbits. When these are in circular orbits, these are not losing the energy, not gaining the energy. So these orbits are called the stationary orbits also. So here he said that angular momentum of that particles is mvr equals to nh by 2 pi. What is the n here? About the around the nucleus, they have given that number of orbits, first orbit, second orbit, third orbit. If it is in first orbit, you can take it n equals to 1. If it is in second orbit, you can take it n equals to 2. If it is in third orbit, you can take n equals to 3, like that. Then look here, one more formula also, don't confuse. These electrons are revolving around the nucleus, means those are having the centripetal force, but centripetal force is not basic force, it is provided by another basic force. Which force is providing the centripetal force? You know that electrons are having the negative charge and this nucleus is having the positive charge. Between negative and positive, electrostatic attraction is acting. This is providing the centripetal force. That's why we are writing mv square by r equals to 1 by 4 pi epsilon naught q1 q2 by r square. q1 q2 by r square. So after simplifications using this one and this one, we are getting the nth orbit radius. nth orbit radius. Don't confuse. This is the impact parameter, and this is the closest distance of approach r0. This is the nth orbit. Suppose we want first orbit radius, means instead of n we are writing 1. If you want second orbit, instead of n we should write it 2, like that. If it is hydrogen atom, atomic number is how much? Atomic number based on that 1, 2, hydrogen, helium, lithium, hydrogen is the 1, instead of Z what we are writing 1. Suppose we are taking this one is the helium, you should take the 2. So depends on the orbit and depends on the atom, this is changing. That's why common formula you should remember that. This is very important. If you can't able to remember this one, at least you can remember that nth orbit, what is the formula? 0.53 n square by z. The 2 unit is what? Angstroms. Unit is angstrom. Suppose the options are in terms of meters. Instead of angstrom you can take it 10 to the power of minus 10 meters. Then come to one by one. When you know the radius, we can able to find out the velocity of the electrons in the nth orbit, nh by 2 pi m into rn. It is also depends on the which orbit it is, and it depends on the close nth orbit radius also. After simplification, you should remember that c by 137 into z by n. C value what is said? Whenever c is said, that standard value is the 3 into 10 to the power of 8 meters per second. When you are substituting, if it is hydrogen, take 1. If it is first orbit, you can take 1. If it is helium, take 2. Second orbit, 2. Like that depends on the and you remember that the electrons which are close to the nucleus, those are having the more energy and more velocity also. When these are like away from the nucleus, that velocity is slowly decreases and kinetic energy is also decreases, but potential energy is increases in that condition. So depends on the number of orbit and atomic number. You can able to find out the radius of the nth orbit, and this is the velocity of the nth orbit, like that. What is the kinetic energy? This is the formula for kinetic energy. 2 pi square k square e to the power of 4 by h square m into z square by n square. So instead of entire thing, when we are substituting all constants, you are getting 13.6. You should remember this one. So 13.6 z square by n square. See how we are expressing, not in joules, electron volts. If you want to convert, instead of 1 electron volt, you should write it 1.6 into 10 to the power of minus 19 joules. This is the expression for kinetic energy. When you remember kinetic energy, 2 times of kinetic energy is giving the potential energy. That's why you look here. Here potential energy is how much? Potential energy equals to 27.2 z square by n square. 2 times of that one. The 2 potential energy, negative energy, both are having opposite sign, and minus is representing attraction between the nucleus and that electrons. This value you should remember, that 27.2 z square by n square. This is 13.6 z square by n square. Like the total energy also same like kinetic energy, but extra minus you are getting. This is the 13.6 z square by n square electron volts. Z square by n square electron volts. So now we know that potential energy, kinetic energy, total energy. Now you look this ratio. Kinetic energy, potential energy is 2 times of that one, but opposite in sign. Total energy same as kinetic energy, but the thing is it is also opposite to the kinetic energy. So this is like heart of this chapter. Okay, angular moment equals to integral multiple of h by 2 pi, this one. And one more thing, centripetal force equals to electric force. From this we can able to derive the radius of the nth orbit, velocity of that nth orbit, and kinetic energy, potential energy. Then you know the ratio of potential energy, kinetic energy. Many times they ask this question, what is the ratio of that? You should remember that one. Then next we are going to discuss about emission spectrum of hydrogen atom. In first year also in chemistry, you know that what is the spectrum. First of all, when the electron is jumping from lower energy to the higher energy level, when it is absorbing the energy, that is called the spectrum, absorption spectrum. Like that, when electron is jumping from higher energy level to the lower energy level, what happens? That energy is coming like a spectrum, energy that is because of the energy difference, it is coming down. So how to calculate that one? Based on that, they have divided that spectrum into different series, but this is the basic formula. nu bar equals to 1 by lambda equals to r into 1 by n1 square minus 1 by n2 square. What is the n2 here? Lower energy level, and n2 is the higher energy level. And you know that this spectrum here, what is that spectrum? First one is the Lyman series. Second one is the Balmer series. Then third one is the Paschen series. Fourth one is the bracket series, and fifth one is the P-fund series. But it is possible, you have to remember that minimum and maximum wavelengths of each and everything. Suppose we can go through the Lyman series. How it is coming that nu bar equals to 1 by lambda equals to r into 1 by, instead of n1 square, 1 square minus, this is the 2 square, like that. Here you should get it. First one is the maximum. From this, when you are calculating this is the maximum. Here lambda maximum equals to, you can get it 1212 angstroms. 1212 angstroms. Like that, here n1 equals to 1 only, but n2 values are 2, 3, 4, like that. When you are taking, instead of that n2 infinity, lambda minimum we are getting, so 1 by 1 square r into 1 by 1 square minus 1 by infinity square. 1 by infinity is the 0. From this lambda minimum equals to, what we are getting? Lambda minimum 912 angstroms. 912 angstroms. So when the electron is jumping from higher energy level to the lower energy level, n1 equals to 2, then n2 equals to either 2, 3, 4, anything you can take it. It is jumped from the second to first, that is giving the maximum wavelength. Then third to first, that is the in between the minimum and maximum only we are getting. Then we can go through the after Lyman series, Balmer series. So what is the difference here? Balmer series, same thing, but instead of n1 we are getting n2, and this is the 3, 4, 5 up to infinity you are taking. Here instead of this 2, and here you are getting the 3. Then here lambda maximum equals to, look here, in Balmer series lambda maximum equals to, you can remember that 6568 angstroms. Like that, lambda minimum, here you are getting the 2 square. Lambda minimum in Balmer series is the 3636 angstroms. 3636 angstroms. After Balmer series, the next one is the Paschen series. In that Paschen series also, n1 equals to 3, then n2 equals to 4, 5, 6, up to infinity you can take it. Here nu bar equals to 1 by lambda maximum equals to, you can write it, r into 1 by 3 square minus 1 by like 4 square. Here you are getting the lambda maximum. This lambda maximum for Paschen series is the, that is 18747 angstroms. Like that, you remember that here lambda minimum equals to, lambda minimum in the Paschen series is the 8202 angstroms. So like that, you should remember for Balmer series over, Paschen series over, then bracket series. For the bracket series, what we are taking, n1 equals to 4, n2 equals to 5, 6, 7, up to infinity you can take it. So this is the 4 square and this is the 5 square. Here lambda maximum for bracket series is the next. This is the Paschen series. Next one is the bracket series. Paschen series, then bracket series. Here lambda maximum equals to 18. This is bracket only, sorry. This is the bracket series. Here lambda maximum is the 40477 angstroms. 40477 angstroms. And here you can take it. This is the 4 square only, that is the infinity. After simplification, you are getting 14572 angstroms. This is about the bracket series. Then last one is the P-fund series. In P-fund series, n1 equals to 5 and n2 equals to 6, 7, 8, like that. Here 5 square and here 6 square. Here also you are getting the maximum and minimum of the wavelength. First I want to share with you maximum 74563. Here this is the 74563 angstroms. then minimum is the 22768 angstroms. So this is the spectral series of the hydrogen atom. Over. This chapter is very simple, no need of worrying about it, just I am giving outlines of this one. First we can start with atom. Okay, many people were there, according to their assumptions, what they have given that J.J. Thomson atomic model. He explained that this is like watermelon or plum pudding model, or pudding model also we can say that seeds are representing the electrons, remaining is the positive charge. Anyway, it was failed. He failed to explain. Failed to explain that why electrons are like a positive charge, why they are arranged like this, and all these some failures are there. Then Rutherford, he conducted one experiment. I think you are perfect in first year also in chemistry. Rutherford alpha scattering experiment. When alpha particles are bombarding with the thin gold foil, that gold foil thickness is the 2 into 10 to the power of minus 7 meters. Then what happens? These are scattered. When he analyzed that one and he given some conclusion about the atom, most of the atom is the empty. The entire mass and that too total positive charge is concentrated at a single point, that is called the nucleus. And he said that always electrons are revolving around the nucleus. So how he explained that one? Already I said that when he is sending 8000 alpha particles, most of the alpha particles are not deviated, means most of the atom is the empty. Only few are deviating greater than 90 degrees and few are deviating less than 90 degrees, and few one in 8000 is retraced back. That's why he said that center is having positive charge and the name is the nucleus. Then when these these alpha particles are coming towards the nucleus, positive repulsion, some gap is set, that is called the closest distance of approach. There what happens? Kinetic energy is equals to potential energy. We have written half mv alpha square equals to 1 by 4 pi epsilon naught 2E ZE by R. That is the electrostatic potential energy. Then Bohr came and some failures, why these electrons are revolving, and he didn't give the clarity about it. But you should remember that radius of the atom is a 10 to the power of minus 10 meters and radius of the nucleus is a 10 to the power of minus 15 meters. Then we discussed about Bohr's, and one more scientist came. He said that when the electrons are revolving around the nucleus, that angular momentum equals to integral multiple of h by 2 pi. Here n value 1, 2, 3 based on the orbit, you should take it. And that too, these are having the circular path, means centripetal force equals to 1 by 4 pi epsilon naught 2z e square by r square. Then you remember Rn, Vn, kinetic energy, potential energy, total energy. Then we can go through the emission spectrum of the hydrogen atom. Thank you everyone. Please subscribe my channel. While referring that crash course, don't confuse. Just you have to subscribe my channel. Then only you will get the physics crash course 2022. Already I have completed many chapters, like part 1, big chapters I have given part 1, part 2 like that. So I have completed units and measurements, part 1 and part 2 is there. Then waves I have completed from the second year, part 1, part 2 is there. And this side, motion in a straight line, also 2 parts are there. Then ray optics also, it's very important chapter for MSET, mains, as usual for NEET. That also part 1, part 2, part 3 are there, big chapter, and that weightage is also more. Then this side, motion in a plane, I have given that 3 parts here also. One is the projectile motion, another one is the parallelogram law of addition of vectors, then relative motion. Don't miss that topics. Those are the basics of that mechanics. Then this side I have given that electric charges and fields, electric potential and capacitance, two parts are there. Then this side I have given that oscillations, only one part is there, and work power energy also 2 parts are there. Better you should follow that. And today I am going to upload these atoms. Okay, almost I have posted that 11 chapters. From these 11 chapters, like you are expecting like 60% from this chapter, this syllabus. Why? I have completed most important topic and that more weightage chapters. Better you should follow that. In this moment you can share my videos to your friends also and ask them to subscribe also. Then I will make more videos. Thank you everyone. Please subscribe my channel.